Hello, and welcome to what will probably be the sixth and final chapter of the Pilot T511 restoration. And this video may run a little longer than the others. We have a lot of ground to cover. We're going to talk about some safety items as well as doing the alignment. In fact, let's cover that first. If you work on these, some people call them All-American 5s. I call them AC-DC sets. That's the term I grew up with. They will run on AC or DC, or transformer-less radios is another term they are commonly called. If you don't take the proper precautions, these are death traps. They will kill you. One side of the AC line is connected to the chassis. Actually, on this set, it's isolated by capacitors and one high value resistor. It will still produce enough voltage to give you a hell of a belt, and if one of those capacitors fails, it will kill you. All you have to do is be touching the chassis, moving it out of the way, touching the chassis, moving it out of the way, reach for a piece of test equipment that has a ground, you're done. The sad thing is, the radio will probably get thrown away, because when they come and find your dead body, nobody will know what to do with the radio, and we'll lose another vintage set. Bleach in the gene pool for not paying attention. That's where my sympathies will be with the radio. It's been said over and over and over and over. Use an isolation transformer. They are available damn near everywhere. Here's one here. This one's good for about 1 amp. 120 volts in, 120 volts out, isolating you from the line, from ground reference, so that you can safely touch the radio and test equipment without getting fried. They're not very expensive. I have some bigger ones, I have smaller ones. A Variac is not an isolation transformer. I've had this argument with so many people, and they insist a Variac's an isolation transformer. It is not. A Variac is an auto transformer, which is referenced to the line. They do not isolate unless they are used in conjunction with an isolation transformer. We have up here on the bench a nice little Heathkit IP5220. This has a Variac. It also has an isolation transformer inside. It says right here, isolated variable output, because the unit contains an isolation transformer in the back, a Variac here to control the voltage, a voltmeter, and an amp meter. Very handy piece of equipment. Not necessary. You can do it with a simple Variac and an isolation transformer. You're going to tell me, but I can't find an isolation transformer. Okay, build one. Hang on a second, I'm going to show you how to do that. Okay, to build our isolation transformer, all we need are 2 normal transformers. Something like a filament transformer with a 6-volt secondary. Just for a moment, ignore the other half of this. It can have a 6-volt secondary, 12-volt secondary, 24-volt secondary, any voltage, doesn't matter, as long as its mate, the second transformer, has the same ratings. You simply wire the 2 matched voltages together. You take your primary here, becomes your secondary over here. Primary in 120 to 6 volts to 120 out. Isolation transformer. You can build it from 2 filament transformers. You can build it from 2 heavy-duty industrial control transformers at 24 volts. You only need an amp or 2 to power these radios. And for the time it takes to wire those together, you can live. You won't get a shock. This will isolate you from the line and allow you to safely touch the radio and something grounded. Okay, you got it? Good. Okay, before we get started, I want to dispel another couple of pieces of bad information that seem to be disseminating all over the internet lately. I'm hearing more and more people say that the tube number, the last digit, tells you how many active elements there are in the tube. Now, that may have started out years ago to try to do that, but however, it is incorrect. Here we have a 12SQ7. It has 1, 2, 3, 4, 5 active elements. Here we have a 12SK7. 1, 2, 3, 4, 5 active elements. Now, the pentagrid converter, the 12SA7, does follow the convention of 1, 2, 3, 4, 5, 6, 7 active elements. It's just happenstance. Down here we have a 35Z5 rectifier. It has 2 active elements, not 5 elements. And the 6Z5 would have 3 active elements. The 35Z5 is a half wave, the 6Z5 is a full wave. So it would have 2 plates and a cathode, 3 active elements. So, well, if somebody tells you that that last number always signifies the number of active elements in the tube, you can tell them they are wrong. There are probably at least 100 cases in an RCA tube manual right off the bat. If you just flip through it, you'll see that that convention does not hold water. Number 2, I've heard a lot of people on a couple of sites saying you start at the front of the radio to do an alignment and work towards the speaker. Been doing this for more years than a lot of you guys have been alive. And I was taught you start with near the detector stage with the IF closest to the detector and work back towards the front of the radio. And you will find most of the service manuals, most of the service information for these radios says the same thing. There may be the rare set out there that has you go the other direction. I'm going to show you that right now. Let's start with the rider's alignment information. Tells us step 1, the circuit to be aligned is the IF, band switch in the broadcast position, low end of the dial, 455 kc for our signal generator. We connect to the grid of the 12SK7 RF amplifier with a 0.1 microfarad capacitor, and the adjustments are 1, 2, 3, 4. Now, 1 is the second IF closest to the detector stage. That's 1. Then it goes to 2. It's the first IF, the one that is closest to the detector stage. Then this particular radio takes you back to the second IF for step 3. You align part of the IF that's upstream from the detector. Then you go back to the first IF and do the 4th adjustment on the capacitor that's farthest from the detector. But you start at the detector, moving away. 1, 2, again back to the detector, 3, 4. The SAM's photo facts tell us the same thing. 0.1 microfarad, high side to the 12SK7 grid of the RF stage, 455 kc, switch in the BC broadcast position, frequency low end of the dial, output meter across the voice coil, a little bit more information. Adjustments, A1, A2, A1, A2, A3, A4, and 1, 2, 3, 4. And let's see if we can find the A1s in here just to make sure that everything agrees. Here it is. Let's get up here. A1, A2, A3, A4. So, starting closest to the detector stage. Now, I am going to hook this up to the isolation transformer and let it warm up. We are going to be using our restored ICO model 315 signal generator. We will be using as an output detector our ICO VTVM model 249. We will be using our Heathkit isolation transformer IP5220. All vintage gear. Now this arguably is a bit newer. I also have tied into the signal generator a frequency counter. We don't necessarily need that because I have made up a calibration chart for the signal generator. And if you don't have a frequency counter but you do have the signal generator, find somebody with a frequency counter and ask them, or go over and ask them if they can work. You can work with their frequency counter for a few minutes and come up with a calibration chart. Common IFs of what I put in: 100, 250, 450, 455, 456, 460. Those are all common IF frequencies. Then on this particular radio, our alignment points are 600 kc, 1400 kc, and 21 megacycles. They call it megahertz today. On 100 kc, I set my dial for 101 and my vernier on 32. For 250 kc, I set my dial for 250 and my vernier at 14.5. And we're going to be doing 455, and I have determined that 25.5 puts me on the vernier dial, puts me right on 455. So let's see how well that works. Alright, I'm going to set up for the 455 kilohertz. I have to go to band B because that's where 455 kilohertz is. I'm going to roll it over to 455 kilohertz, and my cheat sheet here says 25.5 on the vernier scale. I've got to get in front of the camera, sorry. There we are, 25.5. And the frequency counter says 454.7. 300 hertz. Believe me, that is more than close enough to align these radios. That is far, far better than most of them did it in the day, quote unquote. You could be off a kilohertz or two. The radio won't really care on these receivers. Back in the day, they simply would have gone to 455 kilohertz. If they knew somebody with a lot of money, they may have gotten hold of a frequency counter and, done the same thing I just did, is made a calibration chart. The precision apparatus signal generators that were up on the bench just a short while ago all came from the factory with one of those calibration charts. Hang on just a second. Here's one of the manuals that came with one of the precision apparatus signal generators. And this book's called Servicing by Signal Substitution. This is an excellent book. You can still get copies of this or reprints of this on eBay. And this book contains a wealth of information on aligning radio receivers. Inside of this book, you notice it has a serial number down here. Each one of these units from Precision Apparatus was serial numbered, and inside, from the factory, referencing the serial number of the unit you bought, is the calibration chart. 100 kc was 21.1 on the vernier for the precision apparatus, and so on down the line. 260 would have been 28.3. 456 would have been 72.1. All of the common for the day alignment frequencies had a reference in here to the vernier scale. That's how the serviceman back in the day would have set his signal generator. He wouldn't have had a frequency counter. Most shops couldn't afford one. They were just outlandishly expensive back then. Because this doesn't match the serial number of my unit, I've put the serial number of my unit here, and I've made my own calibration chart. 100 kilohertz, band A, 20.55, and so on. so that when I use my precision apparatus, I have two of them now. I simply look at the serial number on the back, match it to the calibration chart, and I don't need a frequency counter to be on frequency. Okay, I apologize if I sound a little bit rushed. I know this video is going to run long, and I'm trying to get through a lot of information here. One, to keep you alive. Two, to try to dispel some myths. Three, get this alignment done at the same time. So you're seeing me turn this set on for the first time. Hopefully the smoke won't leak out. When the magic smoke, high pressure smoke leaks out, you usually have a problem, because I have not found a good way to get the high pressure smoke back into the components once it escapes. And it's obvious everything works in high pressure smoke, because once you see it leak out, the unit usually doesn't work anymore. So we're going to turn on our isolation transformer. Turn it down first. Turn it on. And I'm also going to turn on the receiver. In fact, I'm going to turn it all the way up so that I can hear any activity as it happens. And I'm going to keep an eye on the amp meter as I increase the voltage. The alignment instructions for the radio say to do it at 117 volts. So we're going to start creeping this up. And I'm seeing at 30 volts about 200 milliamperes, and it's falling off because the tube filaments are starting to warm up a little bit, or the heaters more accurately. So we've fallen back off to about 100 mils. Let's go back up. 40 volts, 50, 60 volts. The filament in the dial lamp down here is beginning to glow a little bit. I am seeing a little bit of a glow from the, I think that's a 35L6 in this. Yes, the 35L6. Or is this? Yeah, this is a 35L6. Is starting to glow. That's the audio power amplifier. Our current again has dropped to about 100 milliamperes, so we're looking good. I'm going to bring us up to 90 volts. Usually some activity starts happening around there. Wait for the tubes to warm up. I can see the rectifiers lit. And the current starting to draw. The tubes are getting warmed up and they're starting to draw some current from the power supply. And I'm hearing a little bit of activity from the speaker. A little bit of light humming. That's normal. 100. 110. 214, 117 volts. And I'm hearing voices on the radio. Let's see here. Well, that's interesting. We've got some oscillation. Not surprising, since we put in a new converter tube with some gain. Getting a little feedback here. Oh, another station. But not very strong. Okay, we have a very, very, very broad response on that one strong station, and a lot of oscillation going on here. I suspect that we have a badly misaligned set. I don't think there's anything wrong with it. What I'm looking for is my alignment tools. In fact, I'm going to skip my alignment tools for the moment, because I don't know how hard it's going to be to turn these IF transformers. I am merely going to by ear, and this isn't necessarily recommended, but I'm going to by ear just see if I can peak the IF a little bit. I'm not going to touch the oscillator or the antenna tuning on the tuning capacitor, because I happen to know that station's down this end of the dial. It's pretty close. It's within a few kilohertz of where it belongs. So it tells me the oscillator is probably fairly close, but the IF, I'll bet, is way out of alignment. Let's see what we've got. Oh, we got some motor boating. Okay, I guess it's time we actually went after this with the signal generator. I thought I might get lucky. But let me get the signal generator set up and we'll do this correctly. We have our signal generator set for 455 kilohertz, or kilocycles, excuse me. We have our 0.1 microfarad capacitor in line, as both sets of instructions tell us to do. And the lead from the capacitor goes to the grid of the RF amplifier stage, pin number 4, per the instructions in alignment and both radios. And then working from the detector back towards the radio, or back towards the front end of the radio, we are going to align for maximum signal. And what the heck did I do with my real alignment tool? Here it is. Oh, I got that one pretty close. I'm going to break my tool. These things are so stiff, so I'm going back to a screwdriver. These are grounded screws, so it won't make any difference. See if there's a second peak. There is not. And no second peak here. No. Well, that made a difference. Let's go back and redo it one more time. I'm hearing some motorboating, which is not a good sign. That usually means there's a bad bypass capacitor. It may be the tube itself has too much gain. Maybe the antenna's miswired. Let's see if we have... Yeah, motorboating. We're getting feedback in this set. I am going to move on to the alignment of the oscillator and see if by shifting that we lose this. I doubt it, but I'm gonna try it. Through the magic of YouTube, it's a couple of days later. I had to walk away from this. It was frustrating me because things weren't working correctly. And I had to take the schematic and to the library a couple of times and sit and think. You know, the guys will understand what the library is. And I kept staring at it and staring at it and staring at it. And the more I stared at the schematic, I started to realize a couple of things. First of all, there's a very interesting item right here. You see this resistor? It's grounded on this end, and it's grounded on that end. And I stared at that for a while, and I said, well, maybe this is supposed to be the B minus symbol. And I said, no, that doesn't make any sense, because then we'd have a 150 ohm resistor taking the B minus to ground. There goes our isolation. And there's no path out of here for any current to flow. It's blocked by a capacitor here, it's blocked by a capacitor here. There's nowhere for it to go. This is just, you know, the oscillator coil. And I kept staring at this and staring at this and staring at this, and I finally come to a conclusion. This is a mistake on the schematic. And if you look at the radio, and I've gone in and looked at it, and it is actually wired this way. There's a 150 ohm resistor, one end of it's grounded to the chassis, and the other end is connected to one terminal of the oscillator coil, and then there's a wire going directly to the chassis. Again, this resistor is grounded on both ends. It does absolutely nothing. So what I'm thinking is at some point they either added this 150 ohm resistor to lower the Q of the coil because they had too much gain or something and it was feeding back, or, and they forgot to take this ground symbol out, or they added this ground because the coil wasn't peaky enough, they weren't getting enough of a peak, and they forgot to remove the resistor. Whoever did the schematic change just didn't remove the resistor. Somewhere along the line, I'll bet a change was made to this, and they just forgot to remove the unwanted part. Because if you ground a resistor to the chassis on this end and ground it to the chassis on that end, which it absolutely is in this radio, it doesn't do anything. So anyway, that wasn't what the problem was I came across. Easy for me to say. As I was sitting there staring at the schematic, and I just sit there and daydream and stare at it and try to absorb things, and I spotted this 68K ohm resistor right here on the loop antenna. And I said, gee, I don't remember seeing a 68K or any resistor for that matter on the loop antenna. So I came back and I took a hard long look at the loop, and sure enough, this had been cut out at some point in time, and somebody had rewired this, and it was completely wired incorrectly. Where the antenna comes here and goes through this fixed capacitor, which is in parallel with the primary of this antenna coil, they had taken this connection instead and connected it over here. This end was open, and where the antenna coil switches in and out of the circuit here, they had completely miswired the antenna coil, and it was just in a series circuit with this coil. It didn't really go anywhere anymore, and that's why the radio was deaf, and that's why I was getting so much squealing going on. It was just completely miswired. So we've fixed that, and I'll pull the schematic out of here, and we'll just take a quick look at this. In fact, that'd probably be easier if I stood it up. I put some fresh wires on it because the wires that were on there were just too short to work with. So here's our 68K resistor. Here's our antenna coil. Here's the external antenna wire, correctly now wired to the fixed capacitor, and then to this wire as it should be per the schematic. The loop antenna now is connected to this terminal of the switch instead of here where they had it. This one is now correctly connected to one end of the resistor, so now this antenna can get switched in and out or changed into a series circuit for the shortwave section. Now it works. And if we slide this guy back here, I still haven't aligned this yet. I've still been, or I just got through playing with it, I should say. I just got through playing with the thing. There's the one station we have been getting all along. There's another station. Noise of some kind. Another station. Another one. Another one. And so it goes.
And then after that, it is touchdown, you get to match. No, field goal, you get to match. Touchdown.
And now if I touch the loop antenna, the signal comes up a little bit like it should. Now this set obviously still isn't aligned correctly, but we're getting a ton of stations, albeit they're kind of weak. Now let's try the shortwave. And I'm going to switch the antenna to the external position, and I'm going to use my finger as an antenna. And you see, if I take my finger off and on, we lose the signal. Before, when I did that, there was absolutely nothing. So, now I'm going to go back and I'm going to restart the alignment process. And we'll see if we have any more improvement. I know the IF strip or the IF transformers are aligned correctly at this point. I did double check that, and that's fine. But now we've got to go through the RF and the peaking for the RF amplifier. We've got coils up here in the front, and we've got a lot of adjustments down through here. Trimmer caps here, trimmer cap here. We have a lot of stuff to align in the front end, so we're going to go through there and align everything and see if we can make an improvement in this set. Okay, we're finally, I'm hoping, going to be able to put this pilot to bed. We're home for the 4th of July here. It's 2017. Home from Maine. We've been working up in Maine doing an installation of one of our systems, and came home for the weekend. Have to go up again next week, but we're hoping to get this radio put to bed and this video done so that we can move on to something else. We've squirted a little bit of paint on the chassis. I've got tired of looking at all the rust, and I didn't fill in the pits. Some people go so far as to put body filler on there, but this isn't a museum restoration. This is a functional restoration and just making it look halfway decent. And it came out okay. I think that's going to be fine. Chassis is back in its cabinet. We of course put a little bit of paint on the rusty frame of the speaker also. Unfortunately, the speaker still has a bit of a rattle, but the two people I've tried to contact about reconing haven't answered emails. I will keep looking, and if I can find somebody who can do the job reasonably, I'll probably pull the speaker out and have it reconed. Let's put the back on it and see what it sounds like.
Howie is saving you 50% off your favorite products and services. Howie's cheap fast.
Height has had a hit in each of his last 2 games played, and he's reached base safely in 61 of 77 this year. It's quite the feat.
And there you have it, up and running, ready to give us many, many hours of pleasant listening, if you can call AM radio that these days. But another one is saved from the landfill, and a little piece of history's been preserved. That's about it. I've got to get packed, get out of here in the morning, head back to Maine. We've got work to do. I don't know when the next video will be. Hopefully not too long. Hope somebody found this at least mildly interesting. If you did, please give it a thumbs up. Subscriptions are always welcome. I'm the Radio Mechanic. Take care. See you soon.